All right. 7.4. Now we're getting into logarithms, the whole journey on this chapter. All right, so these two are inverses of each other. So if you remember earlier in the year when we switched, x and y, when we talked about inverses, same concept here. We're just doing the inverse. So log is inverse of exponential, exponential is inverse of log. Now, I'm going to show my Harry Potter nerddom here. So we're going to do a little swish and flick. So when we're going from logarithm to exponential, we start at the base, b for base, and we're just going to swish and flick across the equal sign. And there you have it, b to the x, across the equal sign equals a. And it's just that simple. So I'm actually going to start on the right side here because for my brain, it's easier this way. So 4 to the third across the equal sign, 64. 10 to the negative 3, which should seem familiar because we talked about how when it's negative, that means the number's in the denominator. Back across the equal sign, 1 over 1,000. Swish, 2 to the 5th, across the equal sign, and flick, 32. Now, my brain, I have trouble doing this on the left side. I can't just write log form. I have to swish and flick kind of backwards in my head. So I know I'm going to have a log. I'm going to write the word log. I know my base is 2, so I put that here. And then I actually swish, so 2 to the third, back across the equal sign, 8. So 2 to the third equals 8. Swish and flick, just like 4 to the third equals 64. The big number goes next to the log. So here, the big number in red is on the right side here. So that same big number is on the right side here. Okay, so again, I'm going to start off with log. My base is 5. I swish 5 to the 2 equals 25. And we read this as log 2 of 8 equals 3. Log 5 of 25 equals 2. Log 4 of 64 equals 3. And now the same thing here. I'm going to start by writing log. Here's my base, 1/2. Swish, 1/2 to the negative 2. Come back across, equals 4. 1/2 to the negative 2. Remember, the negative is going to switch positions, so instead of being 2 on the bottom, that 4 is up on the top. Okay, so 10 to the 4 equals 10,000. So again, I'm going to have log. My base is 10. Swish to the 4, come back across, equals 10,000. Swish, 2 to the negative 4, come back across, equals 1 over 16. And again, notice, negative 4, denominator, right? Log, what's my base? 2/5. So I just write a little 2/5 right here. Swish across to the power of, looks like a C, equals D. 1/3 to the Y equals X. My base is 2. Swish to the negative 3, back across, equals 1/8. And again, notice the negative 3 means the number's in the denominator. All right, we can find value of logarithms without a calculator, believe it or not, if we can think of it as an exponential function where the base and exponent will be rational numbers, right? So log 4 of 16, which means exponentially 4 to what power is 16? 4 squared is 16. So you can even do this. 4 to what equals 16? 4 squared. 4 to what power equals 4? Well, that's 4 to the first power. When these numbers are the same, the exponent is 1. Now notice, 4 to what power is that? Now think about it. If it was a 4, like on the previous problem, it'd be 1. Since it's in the denominator, it's negative 1. 4 to the negative 1 is 1/4, whereas 4 to the positive 1 is 4. 3 to what power is 27? 3 cubed. 3 times 3 is 9, times 3 is 27. 3 to what power is 1/9? Now again, just think about what gets you 9. 3 squared is 9. And then we just throw a negative on it to put it in the bottom. And this one's a little tricky. 3 to what power is 1? Anything to the 0 power is 1. So 3 to the 0 is 1. Right? Now, again, forget about the fraction. Just think about the 2. 2 to what power is 16? That would be 4. Right? So, if we do 1/2, we just have to make it to the negative 4. So, think about the whole numbers. It makes it easier. 2 to what power is 16? 4. And since our base was 1/2, but we need to move it from the denominator up, we make it negative 4. Again here, 2 to what power is 4? 2 squared. But it's 1/2, so I need negative 2. Now, notice, think about it, 2 to what power is 8? 3. Since they're both on the bottom, we just leave it like that. 1/2 cubed. 1/2 times 1/2 times 1/2 is 1/8. Right? 7 to what power? You have your cards on your desk. Okay? 7 to what power is 343? And that's cubed. 7 to what power is 49? 7 squared. Now, remember this. The square root of 7 is the same thing as 7 to the 1/2. Right? That's what square root means. So, 7 to what power is 7 to the 1/2? 7 to the 1/2. Okay? And if it helps you, you could rewrite this like this. And it kind of gives it away. 7 to what power is 7 to the 1/2? It's 1/2. These numbers are the same. That's 1. Okay? 10 to what power gives you 1,000? Well, 10 squared is 100. 10 cubed is 1,000. I just said 10 squared is 100. But I need my 10 to go down to the bottom, so that makes it negative 2. Okay, example using function notation. If f of x is log 3 of x, find f of 243, f of 1 over 27, and f of the square root of 27. So what it's saying is you're going to do log 3, 243, log 3, 1 over 27, and log 3, square root of 27. Which again, remember, is the same thing as 27 to the 1/2. So, this is 3 to the 5th power. Remember, 3 cubed is 27, so negative 3 will move it downstairs. Okay, there was a little typo here. There should have been a 3. So that should be 1/3 right there. But now, using our idea from earlier with same bases, we would want to rewrite this as 3 cubed to the 1/3. All right. And 3 to the 1/3 is simply just 1. So what we end up with is log 3, of 3 to the 1. And when those numbers are the same, it's just the first power. That's it.